Okay, so where we left off yesterday was we had just finished simplifying or multiplying this out. Okay, we had taken 4 minus 12i times 11 plus 8i and gotten 140 minus 100i. Okay, you can also, instead of doing the FOIL boxes, you can simply FOIL it out. What does FOIL stand for? You hear math teachers say it all the time. What does FOIL stand for? Yes. Yes, the front, the outside, the inside, the last, or the first, outside, inside, last, either one. Okay, so I could have taken the 4 times the 11 and gotten 44. That's my first times my first, or my front times my front. Okay, outside, I can take the 4 times an 8i and get 32i. Insides, these are my insides. I can take a negative 12i times 11 and get a negative 132i. And then I can take my last one times my last one, negative 12 times the 12i times a positive 8i gives me negative 96i squared. Okay? Negative 96i squared becomes a positive 96 because negative I squared is a negative 1. Negative times negative is positive. And 32i and a negative 132i is going to give me a negative 100i. And I have my 44 in the front. So 44 plus 96 still gets me the 140 minus 100i. So two ways to attack it. One with a FOIL box, one just foiling it out in a nice horizontal fashion. You choose which one works for you. They both should work. Okay? All right, so last one on this slide. 1 minus 7i is our first complex number, and 2 minus 3i. A few moments to decide if you want to make a FOIL box or if you're just going to FOIL it out horizontally. All right, which way do you want to see it? FOIL box or FOIL line? Box, okay. So we're going to write our 1 minus 7i on the outside of our box. And we're going to write our 2 minus 3i on the side. Okay. To get this value, I take 1 times 2 and get, good. To get this value, I take 2 times a negative 7i. Excellent. To get this value, I take 1 times a negative 3i. And to get this spot, I take a negative 3i times a negative 7i. Good. But 21i squared is truly, I squared is negative 1, so negative 21 goes in that spot. So before, when you added just the diagonals, you were only dealing with things that had an I, but because we can change this to a real part, we're going to add both diagonals. Okay, good connection. So 2 minus 21, negative 19, right? Positive 2 and a negative 21. And then a negative 14i and a negative 3i, negative 17i. And we always write our real part first and our imaginary part second to be in standard form. Okay? We would have gotten the same thing the other way. 1 times 2 is 2. 1 times negative 3i, negative 6i. Insides, negative 7i times 2. Last ones, negative times negative is positive. So 7i and 3i is 21i squared. But that, because I did the first times the first, and then I did the outsides. Oops, sorry, that should be 3i. My fault. Thank you. Keep me honest here. Okay. So then when we combine our like terms, I'm going to have a negative 17i again. This is going to be a negative 21 and a positive 2, negative 19. So you may have seen it either way depending on how your algebra teacher taught it. And if you like one method over the other, even though it wasn't what you used in the past, you're welcome to use the other. Okay? That can remind you to add. Okay? Everybody good? All right, next slide. Did I go 2 times? Okay. Now we're going to be asked to solve. Okay? We are solving x squared plus 121 equals 0. Do we see a middle term there? We have an x squared term. We have a constant. Do we have a b term? No. So when you don't have a b term, you can save yourself some trouble by just moving that constant to the other side. Okay? So if it's x squared plus 121 equals 0, I want to take the 121 to the other side so I can isolate the x squared. Okay, how do I do that? Good, subtraction. So x squared is now a negative 121. Okay, until yesterday, you couldn't do anything about this. You would have to say no solution because we only knew about the real numbers. But now what can we do? Good, square root it. When we take the square root of both sides, we are going to get just plain old x. What will we get here? 11i, and don't forget your negative. Because what doesn't negative 11i times negative 11i also get us a negative 21? Let's check. Negative times negative is positive. 11 times 11 is 121. I times I is I squared. But you told me earlier that I squared equals negative 1, so I'll still get a negative 121. So I have to remember every time I take that square root to not lose that plus or minus. Okay, so x is a positive 11i and x is a negative 11i. Yes. Every time we take a square root, we're always going to include the plus or minus. We got into a bad habit in geometry because we were only interested in positive values because we were talking about distances in geometry. But in Algebra 2, always remember your plus or minus. Okay. All right. Do we have a middle term here? Do we have a bx? No. Okay, so what's our first step going to be to isolate our x squared? Good. Subtract 25, minus 25 from both sides. So we get a 3x squared. And both of them are negative, so we're adding them up and giving them the negative sign. And what's 416 and 25? Everybody agree with 441? Okay. Now what's our next step? Divide by 3. We want to get the x squared all by itself. Can't have a 3 there. So x squared is now negative 147. Now what do? Square root it, okay? So when you start making this square root sign, remind yourself, don't lose your negative. Don't lose your negative. So we'll get an x squared equals, well, but negative doesn't have to be in there anymore, right? Yep. Everyone see that it was an odd number, so we're going to divide it by 3. Okay, and when we get divided by 3, we find a perfect square. So 49 is going to come out. The square root of 49 is 7. 3 doesn't have a pair, so it has to stay inside. And then we're going to write this as, oops, and I forgot. I still have my x squared here. It shouldn't. Should just be a plain old x. So x equals, we always write our plus or minus first. We like to write our 7 in front of our I and our square root of 3 at the end. And that's just the way typography, that's the way they do it in all the books. Yep. Okay, everybody good? Yeah. Next one. Okay, so one last step. They want us to find the zeros. So what are zeros? Where the line is going to touch the x-axis. Okay? If our line is touching our x-axis, our parabola is touching our x-axis, those are the places, the values of x, where y is 0. Okay? Those are the points where the y is 0. So we're doing the exact same thing that we did a moment ago, only they've just given us a function. They want the zeros. What does f of x stand for? Y. So we want y to be 0. So don't let the terminology confuse you. You're just solving this. Set it equal to 0 and solve. Okay. So if I have 0 equals 7x squared plus 70, do I have a middle term? No x term, right? So we're wanting to get the x by itself. What's the first step? Perfect. Subtract 70. What's the next step? Divide by 7. What's the next step? Square root. Okay. When I square root both sides, I get good old x. But what do I get over here? Is 10 a perfect square? What are its factors? 5 and 2. No perfect squares there. It's going to stay inside, isn't it? But what happens with that negative? Don't forget the plus or minus. Good. And the negative becomes an I. And the 10 stays inside. Okay. Last one, g of x equals negative 3x squared minus 48. We want the zeros. So set it equal to 0. Okay. So first step, bring the 48 to the other side. Someone else decided to make the 3x positive and 3x squared positive and bring it to the other side. Is that okay? Absolutely, right? Doesn't matter which one you bring to the opposite side. The goal is to get the x squared by itself. Now what? Divide by negative 3. Or if you moved it to the other side, you'd be dividing by 3. X squared. 48 divided by negative 3. I see a perfect square. It'd be nice to us this time. Next step. Square root. So x will be equal to plus or minus I times 4, right? The square root of 16 is 4, so we'll call that plus or minus 4i. Not too bad, right? Yes. Why did the I come before? Because it depends on how you think about it. If some people want to think, I want to get that, take care of that negative in the radical first, I'm going to bring it out, and then I'll deal with the 16. We always like to have the I after the number when we finally, oh, exactly. And over, yep. And over here, we didn't have anything that came out, so it's kind of like a plus or minus 1 I square roots of 10. But a lot of times we just drop that 1 and we don't write it. Okay? Right. Some people like to always have x on the left side. That's okay. You can reverse it. Just extra writing. Okay? All right. So this is going to be your assignment. Lesson 3.2. It's on page 108. Looks like a lot of problems, but they're easy or quick ones to work. Not like graphing that takes a long time. I'm sorry, did I put the wrong page? I think it's 108 unless I mistyped it. We're on section 3.2, page 108, numbers 2 through 32 even, 37 to 43 odd, 49 to 61 odd, and 82 through 84.